In case of dipole, it is P cross E. In case of magnetic field, it is mu cross B, right? Yeah.
Okay, yes, sir.
This is torque equation. We will be detailing it as I've told you already. So this is torque equation for now on face value. This is torque equation, and this is to make the rotor or cylinder rotate about the axis, fixed axis. Find ya.
Yes, sir.
And as it will rotate, the pointer will move across the graduation. There's a calibrated scale. There's a graduated scale. Got it, yeah?
Yes, sir.
Scale that you have graduated. Calibrated scale. As pointer moves, what will it indicate? It will indicate current flowing in the branch to which galvanometer is connected. Got it, yeah?
Yes, sir.
Current flowing in the branch to which galvanometer is connected. So a galvanometer is a device which is connected to a branch in series. Got it?
Yes, sir.
Galvanometer is a device which is connected to a branch in series, and the purpose of galvanometer, which is of course to serve, it is calibrated, is just to let you know in which direction current is flowing.
Yes, sir.
Okay, so if I am speaking of galvanometer calibration, then what I am only to read is the direction of current. It goes without saying, to begin with, pointer should be on even kneel. Can we say pointer should be on even kneel to the scale? Can we say that?
Yes, sir.
Should be on even kneel. That means the pointer should be midways oriented, right?
Yeah, yes, sir.
And if current, which is to flow from right to left, is indicated by pointer shifting to right, so be it. Pointer shifting right will be indicative of current flowing from right to left, and accordingly, left will be indicative of current flowing from left to right, right? Yeah.
Yes, sir.
So this calibration is very suboptimal. Why? Because I'm not reading the measure of current. Are you getting it?
Yeah, yes, sir.
The purpose is not to measure current. The purpose is to get an indication of current. Correct?
Yes, sir.
And also the direction in which current is flowing through that branch. Right? Yeah.
Yes, sir.
So that purpose is served by a galvanometer. This is a galvanometer to me. A galvanometer for its operation, therefore, will draw current from circuit. Got it, yeah? It doesn't have a source of its own. Getting it?
Yes,
Not
sir.
connecting a galvanometer. Of course, this is the construction of a galvanometer. When I'm to take a schematic diagram, then I'm to show you just by a circle. Got it? I'm to
Yes,
show
sir.
you just by a circle. So a circle to me is manifestation of galvanometer. This is symbolic representation for galvanometer, and we connect galvanometer in series with branch. The branch across which current you are to measure vis-a-vis direction. Got it, yeah?
Yes, sir.
So you require torque, right? Yeah. You require torque for galvanometer to be functional. You require torque. Say me yes or no?
Yes, sir.
And you will get torque. You will get torque only if you facilitate galvanometer with current. Fine.
Yeah. Yeah, yes, sir.
And you facilitate galvanometer with current, not from a source which is associated with galvanometer. It doesn't come with any source. So, which current is to feed galvanometer? The current which it is indicating of. Right here, the
Yes,
current
sir.
which it is indicative of, the current which it is suggestive of, that current only is the source to drive the galvanometer, correct?
Yes, sir.
Okay. Now, this being done, of course, just galvanometer will not be of much use to us. So we try converting galvanometer into voltmeter or meter. Got it? Yeah.
Yes, sir.
Very important components of electrical engineering, electrical or electronics engineering. Is it okay?
Yes, sir.
Electrical and electronics, they part ways only for 4 papers, remember. Okay, and that is to happen during last semester. Else, electrical, electronic go together, mechanical, civil, they also go together. So they are sister branches, right? Yeah.
Yes, sir.
So please remember that these are essential components of engineering. Ammeter, voltmeter, these are very essential parts to you. Entire of your 4 year, you will be trying to know on how to operate them. Find yeah.
So, yes, sir.
Okay, yeah. You're asking something, Krish.
No, sir, no, sir, nothing.
Now,
Sure, sir, sure.
this is to be converted into voltmeter. This galvanometer, which comes with, can we say, resistance? This
Okay.
galvanometer which comes with resistance. I'm writing RG for it. Why did I write resistance? Why are we to associate this galvanometer to resistance? Anyone? Why are we associating galvanometer resistance? Of course, galvanometer comprises of coil. Correct? Correct? Say me yes or no.
Yes, sir.
Galvanometer comprises of coil, and coil cannot be free of resistance, correct? Correct? Can coil be
Yes, sir.
free of resistance? Anyone?
Yes, sir. Yes.
Yeah.
So
Yes,
there,
sir.
there is resistance, and that is what being clubbed here, marked as RG. Okay, good enough. This is galvanometer to you. And you want to convert this galvanometer into a voltmeter. Our purpose is to convert it into a voltmeter. So before converting it into a voltmeter, let me ask you on how you connect voltmeter to read potential difference across any 2 points. How you connect voltmeter across those points? Do you connect in series or parallel?
So, parallel.
What is the purpose of voltmeter? I need not ask, as the name suggests, you want to measure potential difference. Correct? Yeah.
Yes, sir.
Want to measure potential difference across points A and B. Let me show you a resistor over here, a load over here, RL, and this point is A to B, this B. We wish measure potential difference across A and B. Find here.
Yes, sir.
So the methodology being, I'll connect a voltmeter across A and B, correct? And I'll connect that voltmeter in parallel. Say me, agreed or not?
Yes, sir.
So this is the methodology. We connect in parallel. Good enough. So if you are connecting in parallel, let me ask you a question over here. I is flowing through the branch, right?
Yes,
I
sir.
current is flowing through the branch. Got it, Krish?
Yes, sir.
And as I current flows through branch, you have an aspiration to measure VAB. That is what you aspire for. You aspire for
Sir.
measurement of VAB, correct here? VA minus
Yes,
VB.
sir.
And VA minus VB as per Ohm's law will be measured as product of I and RL, right here?
Yes, sir.
Okay. So you want your read to equate to IRL. Fine.
Yes, sir.
But in the same breath, as I am to counter my statement, in the same breath, I am to tell you that you will never be able to measure I into RL. Tell me, why did I make such a statement? Why did I make such a statement? Why have we never able to actualize IRL measurement is owing to the fact that some amount of I will at this point part I with some amount of I will at this point A part this I with. And what is that amount? I prime. Got it, yeah? I prime, it will have to do away for some time. It will have to part with I prime. Why did I so? Why did I say so? Tell me. Why am I hell bent on making it part of its point at this point of quantum I prime? What is so tearing need for it? What is the tearing need for the same? Yes, Krish. What
So,
is the need for the same?
so can you repeat the question? I don't understand.
First
So that's
of
why.
all, I'm asking that I will have to part with some amount of current. It will have to
Yes, sir.
part with some amount of current at A. And that parting amount being I prime is what I have taken. Question being positioned at why is it to part with some amount I prime? Why is it mandatory for it to part with it? What
So
is the
because
need for the same?
voltmeter has a little bit of resistance.
Because voltmeter,
Has a little bit of resistance.
yes,
Has
voltmeter comes with resistance. Voltmeter comes with resistance. But Krish, let me say, I want I prime to be 0.
hmm.
Then what can I do? I can increase resistance of voltmeter. Can we
Yes, sir.
increase resistance of voltmeter? How can we increase resistance of voltmeter? In a way, voltmeter is nothing but galvanometer, semi yes or no?
Yes, sir.
And galvanometer, I am to increase resistance. So what I can do to galvanometer? I can
Increase
connect
coil.
this galvanometer very high resistance in series, right? Yeah.
Yes, sir.
If I connect to this galvanometer very high resistance in series, then I'm limiting the value of I prime in voltmeter. Please be careful of the words that I'm using. Okay, and be very careful, meticulous on it. What did I say? I add high resistance to galvanometer and I add it in series to galvanometer, right?
Yes, sir.
And that I am to owing to fact that if resistance is high, then I prime will be less. If resistance is high, then I prime, which will flow through voltmeter, will be less. Correct, dear?
Yes, sir.
So what did I suggest for voltmeter? How can I get voltmeter? When we connect high resistance in series with galvanometer, we convert galvanometer to a voltmeter, right there?
Yes, sir.
And this high resistance is very much desirable. Why is it desirable? Because higher the value of I prime, more is the error in my reading, correct?
Yeah. Yes, sir.
Higher the value of I prime, more will be the error in measurement of VAB. Why so? Because VAB, what we will measure, will actually be I minus I prime into RL. Agreed?
Yes, sir.
So more is the value of I prime, more error we are to negotiate with. Clear?
So the lower part of the
Ye-
board is invisible.
More
Yeah.
we will have to negotiate with. Why? Why we will have to negotiate with more error? Because we are measuring I minus I prime, right? Yeah.
Yes, sir.
Yes, sir.
And I minus I prime will be what to us? Will depend on I minus I prime will depend certainly on I prime. And I prime in turn will depend on what current flows through voltmeter, correct?
Yes, sir.
Can we make this current zero so as to get the optimal read? Can we make this current zero so as to get the optimal read? Any one of you, could you please take call on it? Can
So
you
we
make
can't.
this current zero? Is it possible? Yes,
So
Krish, you are saying.
we can't make it zero. We can make it close to zero because whatever happens, there'll be little bit of current which flows by increasing the resistance to
Let us say, Krish, let us say that we have got a device by which we can increase it to infinity. Let us say hypothetical, we can increase it to infinity. And we are
Yes,
increasing it to infinity. Okay, dear?
yes, sir.
So, will it be possible for me to increase it to infinity? Or should we not go for it per se? Should we not give it a try?
Yes. So we.
Should we try to reduce it to zero?
Yes, sir.
Try to reduce it to zero. The voltmeter per se will be defunct.
Yes, sir.
Voltmeter will not operate, right, dear?
Yes, sir. Yes, sir.
What did I tell you on voltmeter? It is nothing but improvised galvanometer. And what are
Yes,
the
sir.
components of galvanometer? Known to you. For
Yes.
galvanometer to be operative, there is no source. Therefore, it draws current from circuit to which it is connected. Find ya?
Yes, sir.
If you want torque, you will have to feed current to it. Agreed or not?
Yes, sir.
If there is no current, there will be no torque. Thereby, it is not at all to rotate. Needles are not to move.
Yeah. Yes, sir.
Needles of voltmeter or galvanometers to move, you'll have to feed current. So I prime, we cannot anyway reduce to zero. There must be some I prime. Yes, you can make it minimal. You can reduce it to some insignificant value that you are allowed to, but you cannot reduce it to zero. Getting it, yeah?
Yes, sir.
So it comes with a factory default. Can we say that?
Yes, sir.
Voltmeter, any voltmeter that you are talking of, it is to come with a default. It's a given. There will be a default, an innate default associated with it. Correct, yeah?
Yes, sir.
And in that case, we can never get correct read by using voltmeter. Therefore, we have another sophisticated device incoming, and that is called potentiometer. But for now, working of voltmeter should be clear to you. Got it, yeah?
Yes, sir.
What will be VAB? One equation for VAB is I minus I prime into RL, right?
Yeah. Yes, sir.
And the other equation can be, tell me about other equation. Can we write it as I prime into R of voltmeter?
Yes, sir.
And R of voltmeter can be extended to, R of voltmeter can be extended to Rg plus R in series, correct?
Yeah. Yes, sir. Yes, sir.
Yeah.
Yes,
They're
sir.
not visible.
Rg plus R in series, right? Yeah.
Yes, sir.
Believe it or not, all of you, I didn't get a yes from all.
They're
So, but
not
the
visible.
lower part of the bolt is not visible, sir. It's the lower part is
Okay,
cut off.
let me.
And the screen's frozen. Like,
Okay, yes,
Yeah.
yes.
Yes.
It's frozen. Is it?
Yes, the screen is frozen.
Any change?
No, sir.
Okay. Any change?
Yes, sir.
Any change here?
Yes, sir, it's better. But then
Is
it's
it
again
better?
frozen. No.
Yeah, it's freezing
Yeah, it's
on and
freezing
off.
and then yes, sir.
I show
Yeah.
you connected here. My display was connected. Okay.
So even your audio is a
Okay.
little.
Just a
So
minute.
it's
Give me a
broken.
So your voice is also not coming clearly.
Going for connection here.
Yeah. Now it's good.
Now
Yes, sir.
fine.
Yes,
Yes,
sir.
sir. Now, yes, sir.
All good to all of you.
Yes,
Yes,
sir.
sir.
Visibility of board.
Yes,
Yes,
sir.
sir.
Okay.
Not
So
completely,
B
sir.
is this to us. Yes, sir. Yes, Aditya.
Yes, sir, I can see. Yeah.
E is this to us, Aditya. I prime into RG plus RSC. Fine.
Yes, sir.
RG is to be attributed to galvanometer, and RSC is what we have introduced. And what is the purpose of RSC? Purpose of RSC is to increase RV, correct?
Yes, sir.
Increase RV, we want minimal current to flow through this branch, right?
Yes, sir.
What can you say about quantum of RSC? Should be low or high? What should be quantum of RSC? Should be low or high? Quickly, dear.
Sir, it should be high.
Should be high. So remember, to convert galvanometer into voltmeter, we connect high resistance to galvanometer in series. Got it?
Yes, sir.
Convert galvanometer into a voltmeter, we connect high resistance to galvanometer in series with it. Find out.
Yes, sir.
And the purpose being known to you. Questions are asked on these equations. So these are not much for us. We can very well get from the schematic diagram the relation they are to share. Find out.
Yes, sir. So I'm not able to see
Okay.
you.
Sometime they will get your terminology. And the
Sir, your
Yes,
terminology
video
yes.
is
will be
frozen.
Huh? Is it visible?
No,
Sir, your video is
it's
frozen
frozen.
now.
Yes, sir. Yeah. So I thought I was it's not visible, sir.
not visible.
Yes, sir. It's just dark. It's just nothing.
Is Aditya same with you?
Yes, sir.
It's dark.
Yes, sir. It's just blank. There's nothing.
For me, it's frozen.
Ali, where is this? Keep going on.